Sumeet, you guys can start.
Okay, cool. Thanks, Gaurav. So yeah, again, welcome all for today's another session of SDA skills. Uh, the topic for today is sliding window, which is a very interesting and which is like the most common kind of problems that we see in the interviews. So basically, before we start practicing on the problems, I'll just give a brief on like my learning while I was learning about sliding window and some kind of uh, uh, templates that I've seen, like what we could use to solve these problems. So basically, we would use this sliding window technique of technique to solve a problem when the question is more about like there are some interesting questions asked about a window of a uh, ordered numbers. So when I say ordered, the data structures that we would come across are like arrays, strings, or linked list. So those are the kinds of data structures on which we would have this sliding window kind of problems. Um, and yeah, and there are different ways people identify whether this falls into sliding window problem or not. Uh, I can talk about it a little later. Like once we solve couple of problems, we'll have a better idea. So and again, there are three kinds of sliding window problems that we see in common. One is called the fixed length window problem. The other is a dynamic length window problem. And the third one is dynamic length with an auxiliary data structure. So in this session, we have identified one of a kind, and the first three problems are like one of a kind problem. So we can try and see like what those problems are and like how to go about solving those things. And then we have a few more problems which are a bit more complex than a straight, still a sliding window, but a bit more complex, medium complexity in lead code, I think. So with that said, let's get on to our first problem, which is pretty straightforward, I think. So, given an array of positive numbers and a positive number k, find the maximum sum of any contiguous subarray of size k. So, just to explain with an example, so when you're given an array of numbers like 215132 and k of size 3, uh, what we want to find out is what is the maximum sum of a subarray of size k, which is 3. So if you look at this problem, 215 would be a subarray of size 3, and then 151 would be another subarray, 513 would be another subarray, 132 would be another subarray. So uh, what we need to find a solution where of all these subarrays, which is the what's the maximum uh, sum of it. So that's the problem. And since we already know, like we are trying to do it in sliding window technique, so I'll just say like uh, how would the brute force would be, and then we can talk about like how we would solve in the sliding window. So brute force would be like by looking at it like, oh, you want to make a sum of like 215, and then make a sum of 151, and then make a sum of 513, and then 132, and then look at like which of them is the max. So that's straight, right? That's straightforward, right? Um, but if you do that, you would generally run like two loops, uh, for loop on the to start with the overall array, and then for each subarray you would go through the list and find the sum. So that comes to the complexity of n square, right? So uh, this can be improved. Like we would see like some of the some things that we could reuse in what we are doing and can be improved. So So that's the brute force. Just wanted to tell it because we already know, like we are talking about sliding window problems. So instead of jumping directly there, I want to just say, like, if it was in a brute force, you do that, and how we can do it using a sliding window. That said, anybody has any questions or? Okay, so that's good. Okay, so does anybody want to give it a try and see, like, give it a try, or like talk about like how you would want to solve this problem? Okay, so
Is it something? I mean, I'm just thinking aloud based on one of the previous sessions that was held. Is it something to do with that two pointers approach for sliding window?
exactly, yep, that's right.
Okay. Okay.
So
So
2 pointers
we
approach.
just start with, yeah.
Yeah.
And we try to just, move the pointers and that will give us like order of n somewhere.
That's right, actually. That's right. Yeah, it's basically 2 pointers approach that we can take. Uh,
High level idea. Right?
yeah, that's right. That's true. So trying to copy from here, but doesn't allow me. So yeah, that's true. Um, and how would you use the 2 pointer approach to capture the window?
So is it like we are given this number 3, right? So if we start first pointer with the first number and then
Okay.
advance it by k characters, like k positions or k minus 1, I would say.
Okay, let's take an input like this.
Hey Naga, I think can you download that PDF separately into your system that will enable you to copy? I think since it's viewing in GitHub mode,
Yeah,
click
yeah.
download button here, and so you can copy paste easily.
Okay, that's right. Thank you.
Hmm.
Okay, good. Okay. Uh, Someone was telling like the 2 pointer approach, right?
Yeah.
Yeah.
So we start at 2 and
Mhm.
then our second pointer will be at 5.
Yeah, we want to go till 5 because our window size is 3, right?
Right. So then we just record the sum of this, I guess,
Yep.
and then we move the pointers to the next by one, like one step.
Okay. You want to move this pointer to.
So since I have to maintain size 3, right, window
Mhm,
size 3, then
mhm,
I would have to move both the start pointer and, yeah, the whole, basically sliding.
mhm, mhm,
So then I would record the sum of this and so on.
mhm, mhm. Yeah. Yep, that's right. Actually, that would do. But when you actually move the start here, right? So if you start calculating the sum again, so if you look at this
Right,
one,
right. Yeah.
yeah. So if you look
Kind
at
of, I'm recomputing 1 plus 5, right?
yeah, yeah. So you're recomputing 1 plus 5. So this is 8, and so if you move here, so if you
Just
recompute it,
subtract the previous one, like
mhm,
this
mhm.
number, and add the next one.
Yeah, exactly. So whatever you have, you do like 8 minus
So
2, and then
plus
plus
1.
1, right?
Yeah.
So that way, like, we're actually using what was captured earlier,
Right.
right? So, and then you can do the same for the next, and by the time you're at the end, you would actually capture the size, and you you keep maintaining like what's the uh, sizes at each window, and then you could by the time you get to end with O of n complexity, you could get it. Otherwise, like if it was if you were like going back and forth again, it would be like O of size of input that is given, if you assume it as n, and n into k would be the complexity of it, right?
Or n into k.
The brute force, it will be an into K.
Yeah, the brute force would be n into k, and that by using the approach of the sliding window, where we use the sum that was calculated in the previous window, reduces to O of n,
Okay.
right? Yeah. So that's right. That's the two-pointer approach that we take to solve this kind of a problem. This is what we call as a fixed sliding window, where the window size is fixed, right? So we have a fixed window, and the window keeps moving. So this is an example of a fixed sliding window, um, and then that's how we get to O of n complexity, which would have been an O of n square uh, in a brute force way. So yeah, does anybody want to try coding it, or? So, I mean, this problem, I didn't find a straight problem like this in lead code. I think when I searched, so I'm just using the lead code editor to do it. So the lead code ID, the compiler to do it. So if anybody wants, you could also do that, or we can quickly do it, and I can quickly write up, and then we can move to the next one.
I'm sorry if I missed.
Yeah.
What is the problem number in lead code?
Oh yeah, I mean, there's no. I was looking for a very simple problem, but I didn't find that in the lead code, actually, straight problem. So I picked it from somewhere else. So I'm just using the lead code editor to do the problem. So
okay.
yeah, if anybody wants to try, you could use the editor directly with using the problem and example.
I can do it.
Okay, sure. That would be great. So you can share your screen, I think, or I don't know if I can give control. I believe like sharing your screen, Gaurav?
Bhavesh is here. So
Oh, Bhavesh, sorry.
no, I think everyone can start sharing their screen, but only thing is, I think you can paste the problem description in the chat. So
Or probably you can give control so people can just write there.
Yeah. How do we do that?
View options.
In the view options in the top.
Remote access.
Yeah.
I
think someone needs to request, whoever wants to write, and they wants to request, I think.
No, you click on view
In the
options.
center at the top, Naga, the view options. You are viewing after the green bar that.
Oh, okay.
Right there. Yeah.
If you're using multiple desktops, it might go on somewhere here and there.
Oh, okay. I see, like give mouse and control. And who was that who wanted?
My name is Leon.
It should be Amazing Leon. You can search.
Oh, is it? Okay. Yeah. Amazing Leon. Yep. Okay. Accessibility, Zoom. Oh, just give me one moment. Okay. Do have it?
No. So do I type in here? I have to.
Okay, so it's just you can use this editor to.
Okay.
Yeah. So the problem description, I can paste it.
Can I type directly here, or I have to share my screen?
You can type directly here.
Okay. Okay. Good. Let me see. I'm using Java, so.
I
Yeah,
think you can switch. Yeah, you can switch in the top.
Oh, okay. Yeah. So it should pretend that method signature would be the max sum, and define max window. We have an array of integer. Let's say nums and Windows K.
Mm-hmm.
So here, let's see. Okay, so I check the nums equal or nums length 0, and I just return copy 0. Let's see. So equal 0. Say if nums length, okay, less than k, then I just sum them up. See.
Maybe less than or equal to k.
Okay, yeah.
Yeah, if you don't want to handle that case, I can say like question. It would have been a clarifying question. I would say like the case, the size of. Yeah, I wanted to say like the size of array is always.
Okay, greater than.
I wanted to say that, but yeah, because if you want, you can handle the condition. Otherwise, that's fine.
Yeah. Okay. Let's assume that greater than k. Then.
It's always greater than k.
Yeah. So.
Yeah, because that's it. The question was to demonstrate the fixed builder. So yeah.
0. So I equal what k. No. Let's see. I equals 0. I less than plus I. So let's say first result is not I, but I need to check for the condition that if I great okay, so let's say if I is greater than or equal k.
Mm-hmm.
Greater than k, right? Because we want k, but we use base 0, so we have to say greater than or equal k. And in this case,
Decrement the last.
Okay,
the
so
left side and add the right side.
Could you explain what your approach is here?
okay,
I'm
so
a little lost on.
Okay, so the
10 and 11
it's greater than k. That means we go to the next window. So what I'm gonna do is I subtract the result, you know, from the previous element. Yeah, maybe like.
You can use I minus k relative index. I minus k minus 1. I think, I don't know if.
Well, I'm trying to understand what I represents for you. Does it represent the first index, the first index in the window, or something else?
No, I just keep it going. So you know, when I is greater than k, and then you know, I will recompute them. I will remove the previous number from the window and add the current number to current window. Does it make sense?
So
let's say, okay, sorry.
I see what you're saying. I see what you're saying now. Okay. So what you're doing on line 14 is you're always adding the value you're on, but on line 11, you're checking if your index is k or more steps away from the beginning of the array. So you're trying to check if there's something to subtract.
Right.
Okay.
So maybe right here, I'm gonna do max. Instead, do max plus nums I. Okay. So when I greater than k, that means I'm on that window. So what I'm gonna do, I'm gonna compare the result. Would be equal max of current result and max. And now I begin to I remove the previous number from max. So max will be equal max minus result I minus k minus 1.
Result or the nums you want?
Oh, I'm sorry. Yeah, the num. Yeah.
So you want to subtract the start of the window, right?
Right.
Why are you using max here? Like it should be.
What do
right?
so?
Oh, sorry. If max was a sum, sorry.
The variable names is.
Does res represent your the current sum for the window you're on?
Result is the final result. Max is the max so far at this window. Maybe I should say max so far. Right?
Yeah, you can say window sum.
Yeah. Or maybe.
Yeah, naming should be like something like window sum or representing current sum.
Yeah.
So yeah, once we are done, I have some template for this, which would make that easier. But yeah, go ahead. Yeah, win some. Yeah.
Yeah. So.
So why does line 12 happen before line 13?
Because that is the previous window. You know, we haven't computed, so we want to find the max of that window before we recompute it.
What do you mean the max
you
of a
also need
window?
Yeah,
I
for
thought
example,
you were summing everything in the window always.
For example, we have 1, 2, 3, 4, right? And then, you know, up to line 11 is we have, let's say k equal 3, and up to line 11 we have a window of 3, which is 1, 2, 3, right? So we will find the result. You know, find the max will be up the result.
Okay, I guess here. Okay, I see. You haven't updated the Windows sum. There's nothing in your code yet. That's why I'm confused.
Yeah.
So the
because
Windows
I
sum.
change the variable,
line
but that max is the same as Windows sum. Yeah.
Okay, we're getting the Windows sum.
So why? Okay, so the question is, why is line 15 happening before this if condition? Let's see.
It should be moved before if.
Yeah,
Like,
as soon as you get into the start.
wouldn't you like, I'm not seeing why line 12 has to be inside this condition.
Okay, so
Like, my impression is that you always add the one you're on, and then line 13 represents subtracting, something that's in front of, like, that came earlier, that's in front of the window.
okay, so
So that's a condition, but then that fits the condition, right? Like, if your index is far enough into the array, then you can start subtracting stuff off the left end. But line 12 to me doesn't seem like something that you do only if,
Right.
only if you're somewhere in the middle of the array. It
Line
seems to me like
12
something you would do on every step.
In line 12, result RES is the previous window sum, and the window sum is the current window sum. We are comparing these two and taking whatever is the result.
Right. So why are you comparing them only if you're, like, why are you comparing them there before you've added something to the window sum on line 15?
because the window size at least had to be window size K, right? So, we only meet the window size when I, greater than or equal K.
Yeah, so one thing is that we cannot, I will be after 3, index 3, the I will be always greater than K, right? So we need to have some logic there where you want to have.
You need to check modulo, I guess.
Yeah, so I is an index which is going through the whole array, right? So after 3, I will be always greater than K.
Yes, but that
so
we have a new window, right?
So that's, I think it looks fine. What we are doing is that, whenever we are going beyond, so whenever we are at K plus 1 position, from there onwards, right?
Mm-hmm.
We always negate the last things that is going out of the window.
Yes.
And
okay.
we have to keep doing it, right?
Okay, but here's my problem. Once you get to the very last window, you haven't updated the result.
That's correct. So that might be a problem.
Yeah, that's a problem.
Yes, I agree. So let's talk. Yeah, let's talk about that problem. Okay. So
the sum should be before, like line 15 should be before if.
Maybe that is fine. We can take an example and run.
Yeah.
Right?
I think there might be a problem, and there can be a solution that can be fixed outside of for loop or somewhere else. But let's run through one example. And in an example, maybe where the greatest sum is coming from the last window.
Right. Yeah.
Okay. The last window.
Yeah. That's right. Leon, do you want to take an example, or do you want me to take it?
I see that's
do you want to finish it up? You can finish it up, and then we can run it.
Maybe
it might work, but there might be one bug.
I think
I have to
maybe a
move this one
bracket
to
or something like that.
to the top. Yeah.
Yeah. That makes it logically.
Yeah. So I make sure. Oh. What? Okay, maybe I just type. Sorry. So that one would be. Okay. So in this case, I'm. In this case, let's say if it's I first, and I will check that, and then and I subtract the previous one. Yeah, I think that's fine, right?
Yep.
Yeah.
I minus K3 minus 1. Yeah.
I might be off by 1. Maybe K minus 1. Was it like K minus 1 because it is 0?
Mm-hmm. Yeah. That should be good. I is less than or equal to K. So whenever you get to, yeah. Okay. Yeah, I think it might be one off, but let's take an example, run it. I think that makes it clear.
Okay.
Yeah, I think
You
it
can take
should
an
be
example
equal
of,
to K, because only when you passed that current window, you need to make sure you are deducting right.
Yeah.
Yeah.
On line 12.
Yep.
You don't need K minus 1. Unless you want to just make it more than.
Okay. Because it base 0, so let's say, I'm thinking if K equal 3, then, I have to be at index 2, right? 0, 1, 2. So that will be create one window.
Right.
Oh yeah,
You are
because
right.
you are
Since
collecting
Your
inside.
problem on
Yeah,
line
you are
14.
collecting inside. Yes. Yeah.
and you
On
have a
line
condition
14.
like I greater than or equal to, so it has to be K minus 1. Yeah.
Yeah.
Yep.
So
If you, for example, if K is 3, then you only want to subtract, you only want to line 14 to happen when I is 3. What you have on line 12,
Yeah, that's a good point.
that's going to get invoked when I is 2. So
Yeah, you have.
Oh yeah, so 14. I think you could remove the minus 1.
minus 1.
I mean, my preference would be to adjust line 12 rather than 14, but you could do it either way.
Okay.
Can we run through one example and see where the problem is?
Yeah. Okay. So let's do 1, 2, 3, 4. Yeah, okay.
So you can take the example from the handout. It has the final window as the.
Can you tell me what the number is?
Can you copy? Yeah.
If you go little up, it is there, I think.
No, it was in C++.
It was in C++.
Oh, okay.
I can paste it for you. I can quickly paste that for you.
Okay.
We can remove 2 if you want last 2, if you want the last window.
Yep.
Okay, so K equal 3 right here, right? So let's say first I equal 0, max will be 2, right? And then I equal 1, max will be 2 plus 1 is 3. And I equal 2, max, I mean the window, so current window is going to be 8, right? 3 plus 5.
Can we keep track of I and win sum also?
Yeah.
Let's try go step by step. I would also put some indexes on the top. That way, like where you are.
Okay. Yeah.
0. Sorry, do you mind?
Yeah. Go ahead. Yeah.
3, 4, 5, and then you have
Win sum.
result. I'll just put it here. Result is equal to 0, sum is equal to 0. Okay.
And
Now
start
when I is equal to 0 and when sum you add 2, 2 plus 1, 3, and I is equal to 2. It becomes 8, right? and then we have k as 3, k as 3. Okay, so now you have like I is still is equal to k minus 1, which is 2 now. So you get inside the if loop, if condition, and result is equal to max of result and win sum. So win sum here is 8. So we have the result as 8 here. And then win sum minus I minus k minus 1. I is 2, k minus 1 is 2. So win sum minus 0. Win minus nums of 0, which is 2.
924 is not written that way.
Correct.
924.
K is 3 here, I is 2 here.
Yeah, so minus 1, right?
So 2
Well,
minus
if you look
2
at
is
line
0.
24, it looks like 2 minus 3 minus 1.
Oh, I have to plus 1.
Okay, yeah.
So maybe plus 1.
Okay, so what we want is, we want to, when we are here, we want to subtract 0. So I is 2, I would say it is...
But you don't want to subtract 0.
I mean, the value in the 0, right? We want to...
Why? You have a window of size 3 exactly. Why do you want to take it off?
To prepare for the next window.
Yeah.
Okay, so you're doing it ahead?
Yeah.
Yeah. So I think it will be plus 1 at 24.
Yeah, plus 1 in there.
Yeah.
So let me just fix it quickly.
Yep.
Okay.
Yeah. Actually, yeah. Right. So now, yeah. Now the win sum is I is equal to 2 plus 1 is 3, 3 minus 3, 0. So win sum becomes 8 minus 2, which is 6 here. And then we go back to the loop. I becomes 3. And win sum we add 6 plus nums of 3, which is 1. It becomes 7. And then now I is 3. 3 is equal to, no, 3 is greater than, 3 is again greater than k minus 1, which is 2. So we again get into the if condition. Now the result checks again what is max result or win sum. 8 is max. So we proceed. And then we subtract from win sum, we subtract I minus k plus 1, which is 3 minus 3, which is k is 3. 3 minus 3 is 0 plus 1. So now 7 minus nums of 1, which is 1. 7 minus 1 is 6. So, and then we go back into the for loop. I is 4 now. So now we add a win sum nums of 4, which is 3. So win sum 6 plus 3 is 9. Then we get into the if condition. 4 minus 4 is greater than k minus 1. So we get result max of result and win sum. So now the result is 9, right? So, and then win sum minus I is 4. 4 minus k. K is 3. 4 minus 3 plus...
Yeah, plus 1.
Yeah, 4 minus 3 plus 1, 2, which is win sum minus 5. 9 minus 5 is 4. So then we get back to the loop. I is equal 5. And then win sum plus I of nums of 5, which is 2. 4 plus 6. And then we, if condition would always go into the if condition from then on. I think like 5 minus k minus 1 is, 5 is greater than k minus 1. So we get into the if condition. Then we see result, max of result and win sum, which is still 9. and then winsum minus I minus k, phi minus 3 plus 1, which is 3. Winsum is 6 minus 1, which is 5. And then we go back here. I think it's already greater than yeah, post, right? So it becomes 6, and then it comes out of our loop, and that should do.
We
I
just
think
need to return the Winsor.
Yeah, I think, yeah, that's all.
Yeah, I
Res,
agree.
right?
This one is kind of
Not
confusing
Winsum, it's res.
for the index. It does not very look very clean. I mean, look not really intuitive.
No,
Sorry, what are you returning?
You
at
should
the
return
end?
res, not Winsum.
Yeah, yeah.
Yeah.
Yeah,
Oh,
we
yeah.
should return res and not its and is that all positive problem? Is that given?
Yeah, yeah.
I mean a positive integer.
What is
Okay.
given?
Yeah, positive integers. Negative would make it more complex. So the intention was to make it.
I don't know if it matters here actually.
It
does.
Well, we have to start
Where,
res with
when?
probably int mean if I think it is negative, and I'm not sure. Yeah.
Oh yeah. Oh yes, yes. Okay. Other than that, though, is there an issue?
Yeah. Yeah, I think everything else should work.
Okay, yeah, I didn't try it myself, but I was looking like somebody had the question in the channel. So yeah, we could give it a try. So do you want to run the example, or do you guys think we should move to the next question?
I think we can move to the next one. But
Yeah.
I have a question.
Yeah, yeah. Mm-hmm.
You know, what would you do? I mean, like at line 20, maybe 22. You know, what would we do so that make it you know, easier to remember?
Easier to remember so that you don't have to check the condition.
No, I mean check the condition, but easier to remember, like the window, you know, because
Like when to do
yeah,
k minus 1 or when to do k plus 1 and those kind of things.
Yeah. Actually, I mean, like we really did not use 2 pointers here, right? We did not use like 2 pointers and tried the approach. So the way I wanted to look at it is like you maintain these 2 pointers, the start and end, and whenever you go beyond the limit, then you use the start pointer to subtract the value. So I have a solution I can even show. Or
Is this what you are referring as template?
yeah, that's what I was referring as template. Yeah, I think once we do a few more problems, we can compare all the problems to see like how we could actually templatize this, right? I mean, like the point of learning this pattern is like we want to know, like we want to be comfortable, like moving the windows, and we want to be more comfortable about moving the windows, expanding and contracting the windows. And if we have a templated pattern to deal with those things, then we can focus on the core logic rather than focusing on how we move the windows and how we expand and contract the windows. So that's what I want to show. Like once we have the solutions, probably if we look at those all 3 problems and compare them, the template might make more sense. So yeah, and again, if you look at it here, like we haven't used the 2 pointers, right? If you use 2 pointers, the code might look something. Oh, actually, you know what? Here. Yeah, if you look at it, so this is the window. No, this is not. Okay. Let me go to the. So we could use something like this to calculate the window size, and then have a local sum of the window and always use the max sum. And here we are using 2 pointers. One is start and end pointers, and then making the window sum and getting it. Okay. So I believe let's get to the next problems and then see like how this template makes sense and how that will be useful once we get into the complex problems. Agree, guys, or do you want to spend more time on analyzing this?
Yeah, that's
I think we'll move to the next one.
Yeah. Okay, let's move to the next problem. Okay, so this is the fixed window problem that we did, where it's like the window size is fixed. So what we are doing is just like moving the window forward and getting the window sum and getting the value. So the next problem is a dynamic window where the window size changes as per the requirement that we have. So here, given an array of positive numbers and a positive numbers S, find the smallest consecutive subarray whose sum is greater than or equal to S. Right. So here we are that sum is fixed here now. Earlier the sum is not fixed. What we were trying to find is the sum in a fixed window. Here it is like we want to find an array, subarray, which is greater than or equal to S. Right. So here the window keeps expanding and contracting based on the logic. Right. Did it make sense, or do you want me to take this example and run it?
Could you please run the example?
Yeah. Oh, I don't know. I thought I had the PDF downloaded.
So I think Naga, this question is on lead code also.
Oh, is it? I didn't find the exact problem, so.
Yeah, 209.
209. Okay. Oh yeah. Okay. Okay. So okay, so in this example,
So basically here we want to see a window where the sum should be either greater than or equal to 7. And it should be the minimum window.
yeah, it should be the minimum window.
So in this case, there are different windows. If you see like 2, 3, 1, 2, there are more than 7, but 4, 3 is the best one. It's smallest.
Yep, 4, 3 is the smallest. So in this, we take the same window. We start the 2 pointers here, and we take 2, 3. If you take 2, 3, the sum is less than
7.
7. So we expand the window, which is like 3, 4, 5, 6. So which is still less than 7. So now we expand it to the next number. So that becomes 6, 7, 8. So now we store this, which is greater than 7. So
Yeah, this could be one answer.
This could be one answer. And now we want to see if there are any other windows. So now what we do is like we compress the window from the start. So now the window becomes like this one, 3, 1, 2. Oh, right.
Equilibrium 6.
Yeah, 3, 3, 1, 2, which is oh, sorry, I should have captured the window size earlier, not the sum.
So earlier the window size was 4.
Window size
Is there a reason that, what's the reason not to check all windows of size 2 first? Or all windows of size 1 first,
No,
and then
we
all
have
windows of size 2?
technically we have checked that, but we want the sum should be more than 7.
Yeah, the condition here we have is.
Well, here's the thing. Here's the thing. If you find a window of size 1, you know that it's the smallest. You don't even need to check the windows of size 2, 3, etc.
No, but we
That's like a brute force approach. Okay, like what if if you get lucky and the window size is 1, then that'll work. But what if the window size is like the length of the whole array? Then you have to scan the whole array, like for every possible window size from 1 to n.
What Naga did, we already
is
did for size 1. So what Naga did, we already did for size 1. So he started with the first index 2, which was less than 7. So he increased his window size.
So if you look at this one, right? So the condition we have is the size of the window, the sum of the window has to be greater than or equal to 7.
So
right?
Naga, what you can do is
what I'm saying two things. The first is that we already know that if you increase the size of a window by 1, it's that the sum is the same as the window that's just one size smaller plus that element, right? So we can use that to our advantage if we need to. But the second thing is that since we're looking for a smallest size window, I would think to check all the small windows, the smallest windows first, because if we reach something where the sum fits our condition here, we're done. We don't need to check larger windows.
So
for example, if there was an element 7 at the end, I think that's what she's saying.
Yeah.
Had an element 7. Then.
But
that's still a brute force solution though.
So let's rethink that approach, right? So what you're saying is
it's not brute force if you code it as
Here is the thing. So your approach, let's say that first check all the one size of window 1 and check all. Is that correct? If you don't find, then increase the size of window. Is that correct interpretation?
Yeah, essentially.
Okay, so let's.
Yeah, but the point is to use to our advantage the fact that
I understood. Okay,
anytime you have a window of a certain size, you just take a known sum that you've already computed and you add the next element.
That's fine. So we are looking for all 2. Then we are looking for all 3. Is that correct? So
that's what I would do.
Okay, so
that would be an n
I
squared
think there is a
solution.
problem with that because they have given the array is like we need to find the continuous subarray. We'll end up calculating multiple times if they for the same array, like the sum, right? If like for the count
so
1,
that's why I'm
we'll
saying
check once.
you need to use the fact that you've already calculated a subset of the window that you have. So if you're looking at a window of size 4, you've already calculated the sum for a smaller window of size 3 within that set of 4. So
But
you
you're
could just
saying
add
we'll
one.
start from 1, right? We'll start from 1 digit and then two
So
2 digits.
Yeah, you're just building, but the point is you're not actually like searching through the array and computing stuff all the time.
Okay.
It's not.
Okay. Do you mind putting that here in a little bit more concrete way? We can
Maybe
see that.
there's a better approach, but I don't know of a
No,
better
but if you just
approach.
think, okay, so hold on, but so there's n possible sizes for the windows, right? You could have a window size 1, 2, 3, up to n. And then each one takes at least n to scan through the whole array. So that's an n squared solution at least. Whereas and that's really not what that's not even what the sliding window approach is. Like the sliding window approach is that you have a dynamically resizable window size, and you can make just one pass through the array, and then you can get your final answer.
So
which is guaranteed to be O of n.
So there could be multiple ways of doing it.
The idea I had also only makes one pass through the array.
I think that's let's take one approach and discuss. I think what Anna, you're saying is if you are doing one pass, so either we can have a constant sliding window or dynamic sliding window. If you are saying that we want to have a constant sliding window and pass the whole array with the size 1, and then we want to pass again the whole array with the size 2. And then pass the whole array.
You don't actually have to pass. You don't actually have to pass the whole array again because you already know where the elements are. To compute the next sum,
So how would you do that?
So
or probably you can share your
example because
it's a simple concept. It's something like this.
I can give that control
I'm going to type it into the chat. Some from.
No, I can give the control to you, Anna.
And share.
If you want, you can use this example.
It's okay. I'm just gonna type it into the chat because it's simpler.
I can paste it here.
I think definitely that approach will work, but that won't be the best approach. I think in the worst case, it can hit to like n square.
I think the approach, what is getting, what I think Anna is mentioning is like a pre-sum of the computer pre-sum.
There is the chat window. Oh yeah, chats.
Are you? Can you keep sending your thoughts so that we are not waiting for the whole.
Or probably we'll Naga, you finish and then we can come back to that.
Proposing to use this information from my.
I think Anat, maybe if you type in the shade window, all of us can see it. I'm trying to paste it back, but do you mind? Like I have already shared the screen with you. You can use the editor in front of on the lead code.
Oh, how?
Oh, how? Okay. So I believe.
How would I control this?
Okay, hold on. I think, did I close this window?
I think the last tab, Naga.
Last tab, okay.
I mean,
yeah.
maybe it's not the right approach, but the point is, I would basically keep a running list of the current sum from index I to j for any pair ij, and I know that if that every every window of size just one more is simply a simple computation, right? Like I don't actually have to pass through the array more than once to make this calculation.
I think sliding window is also same what you're talking about it, Anna. I think what you're saying is like pre-computing that is like more dynamic programming, which requires more memory. I think when you convert into sliding window, it is similar to what you're trying to say, I feel. When pre-computing, like, even in sliding window, we are pre-computing and reducing the window.
Okay. All right. Let's see how, yeah, then let me see how this works. Make this maybe better.
Yeah. Okay.
And Naga, what you can do, like at the
Yeah.
end, you can put 7 also after 3. So it will.
Oh yeah, the whatever Anna is talking about, we would.
Yeah, so it will eventually get computed.
Okay.
So if you put 7 here, it will eventually get computed.
Okay. So another idea is like because we want to get till sum greater than or 7. So we are. Sorry, I think we went back. So this would be like 3, 4, 5, 6, 7, 8. So the window size is 4. And now that the window size is, Windows sum is greater than 7.
Naga, do you want to track the start index and the end index as well?
Yeah, that's equal to 0 and is equal to 4. And in window sum, I'm computing the window I'm working on. So this will be the min window size that I want to compute. So here the window size is 8. So if you look at it, and this 3. So right now, if you look at it, like the window size is 4, and the sum is 8. So we got here, and now that it is above the sum that we wanted. We want to check if any of this windows, like which we would make a number which is less than which could also make a number which is equal to or greater than 7. So that's the reason what we would do is like we would shrink the window from the start to see if that makes a number which is again the number that we want. So that makes the window start to 1. And see like window start to 1. So, and then the
Subtract to like the start value.
Yeah, window sum minus start value, which is 2. Sorry.
6. It becomes 6.
It becomes 6. And because 6 is not the value which is greater than or equal to 7, now we want to start expanding the window again until we get to a point where the value is actually greater than or equal to 7. So we go back here, and then now the window size is 6 plus 4, which is 10, and which is greater than or equal to 7. The end is 4 now, and the window size now is again 4. So it's still not the minimum window size that we wanted. So, but again, now that we got the number, we want to see like by shrinking the window from the start, if we could still get a number which is greater than or equal to 7, right? Because our idea is to find the minimum window. So by adding this 4 here, we got a number which is above 7, but there could be a smaller window by using this number, which could still be greater than the number that we are interested in. So that's the reason we are trying to shrink again from the starting to see if we could get that window. So that, so I'll get rid of 3 from here. I shrinked it from the start. I get rid of 3 from here, which is minus 3, which is 7. So you see here, like we got another window by using the new number that we added. By expanding the right pointer, we still got a window which is equal to 7. And now if you look at it, so the window size is 3, right? Window size is 3. And the minimum window size that we got so far was 4. Now we can update it to 3 here. And then now that because this is still a valid window, we want to try again to shrink again to see like, I think in this condition, it would not make sense to, because we are equal to 7, I don't think it makes sense to compress again to see. Right?
Yeah, probably it'll just be the next iteration of your for loop, and it'll
It
just
would
expand.
if the next number is
Are we
0, 0,
told that,
0.
Oh yeah, you're right. Yeah,
that
yeah.
all the entries in the array are positive? Are all the, if the, all the entries in the array are positive, then you don't need to compress.
Yeah, yeah. I think 0.
But you can, you would shift over both, I guess, both indices.
Probably 0 would, if there is a 0 in the index 2.
What do you mean?
If there is a 0 here.
But I thought all the entries are positive.
I think 0 is considered both positive and negative, right?
But
okay,
what
I understood it to mean that all the entries are more than 0, but okay.
Here you can shrink your window, right?
Yeah.
Naga?
Shrink a window again, right? Yeah. That's what I was thinking. Okay. So now we shrink again to see
your sum became less than
yeah.
So it's time to again expand the window.
Yeah, it became 6. So it is not the value that we are interested in. So we expand it again. So now this window sum has become
9.
Yeah, just a window between, but yeah.
So this could be one answer, but you already have a min window size of 3.
Window, and it's another 3. So now I'll start to shrink the window again.
I have a question there. So when you were at 1 to 4, the sum was 7, right? So as if we assume that it's only like greater than 0 numbers, then how would we make a decision whether I'm going to like right now we contracted it, right? We moved to 2. So how did we make the decision that instead of contracting, I won't just go to the next step? Because already sum was 7 there. So
Yeah. That's the discussion that we were having, right? So either we can make a condition that it has to be always greater than 7 to contract, or greater than or equal to, right? In case of we have a condition saying greater than or equal to, so that's because I made an assumption here that's a valid question. I think, I mean, I made an assumption here like 0 is both positive and negative, so you could still have a 0 in this array.
Right. Okay.
Right. So if you have a 0 there, if you have a 3 here, then that would still make a 7, right?
Oh, 0, so you are just following this approach considering 0.
Yep.
Okay.
Yeah.
Yeah. If not, you just can make it like only greater than 7. Make sense? Okay. So then now, because the value is greater than 7, I compress, I shrink from the start, and the value is 7. Oops, sorry. Sorry, I was not changing my indexes.
I think that's fine, Naga. We can see when you're moving the window.
Yeah. So the window size is 7 here now, and then the minimum window size is 2. So now that we have a 7 here, I could, by using our earlier approach, I'll compress it again. And now the start and end have become 5, and the window size is 3. So that that doesn't work for us. So we expand it again. So 3 plus 7, which is 10. which is greater and greater than 7, and we could yeah, so because we added 7, our output window is not right. So we got a window sum of 10 here, right? And the window size is 2, so it may not be of interest for us again. And now we shrink it from the start again, and now we see a 7, which is still what we want, which is of interest for us. So and the window sum is 7, and then the minimum window size is 1. I think that should do. Actually, after this, then the end goes out of bounds, so we end the condition, and the minimum window size is 1 here. So this is because, like, if you look at this example that was given in the lead code, it was 2, but now we added a 7 at the end, right? So that because of which it became 1 here.
Yeah, correct.
Yeah, and did it make sense, guys, or do you want me to just go over it quickly? I think the idea
No,
is.
it makes sense.
Yeah, yeah.
It's very nice to like, it's very obvious that it's ON.
Yes. So,
yeah,
Anand,
yeah.
so whatever you were telling, is it the same approach? Now we can come back to that, or it is pre-calculating sum and doing something else?
Sorry?
So
Well,
whatever approach you were proposing in the beginning, is it the same approach or a little bit different than this? Because
it's different, but I don't actually think it's better for this type of problem. But there are other problems using arrays where maybe you don't have a contiguous set, or
so can I add something?
You're looking for something else, where it's useful to know, just like to have the computed value for a subset and then keep growing and growing and growing the size of your window. I feel like that approach could be used for those problems, but for this problem, this approach is better.
So Anik, I also looked in the same way, like what you mentioned. I also thought in the same way. Then the only catch here is, it is not, if the sum was equal to S, then that approach would have worked. But here it is mentioned sum could be greater than equal to S, which
yes,
there we can't use that property. It has to be fixed. So like I mentioned, like if the question was like sum is equal to S, then we could have used that. Then it could be used. That approach can be used in 2 variations, either to find the largest length or to find the minimum length. Either way we can use that approach. But here, because the constraint was little different, it is not equal to S. That's why we have to go with this approach.
Well, but in addition, there are here you are looking for contiguous subarray. So like you're looking for like the sum over neighboring indices. So it's like there are other problems involving arrays where I think basically breaking it down and starting from small windows to larger ones is better. I don't have a good example off the top of my head. Maybe some like I'll bring it up if I remember a good example.
Okay, makes sense.
But yeah, I like this approach better for this kind of problem.
Yeah. I mean, it's a pretty standard sliding window 2-pointer approach. I think it's a kind of a templated approach for this problem. Okay, that said, I think we're almost going out of time. Does anybody want to try the solution?
Yes, I want to try.
You want to try, Yashwant?
Yes.
Okay.
Sure.
You can, do you want to take control or do you want to share screen?
Like I'm using mobile. Can I type using mobile? Is that possible? Yes.
You're using what?
Okay, I joined the session through mobile. Okay, can I type it through that?
Yeah, I believe so.
It would be tricky if you're doing it mobile.
Interesting.
I would be
but
very
let's see how
you would.
Naga, you want to see how we are doing on time? How many next few questions, or is
Yeah,
it
we
better
had
we just get the
5
solution
questions
and
actually. If you want, I can code the solution and then move on to the. But
up to audience?
Yeah, I think
Like,
we have more
I think
questions, but we just kept it purposefully. So we'll just see that as long as everyone understands what we are trying to talk through, then it's okay to
Yeah.
skip 1 or 2 problems from lead code. So
can we show the template?
Okay.
yeah, I think that will be helpful, like the solution
Okay.
for this one, and then we
So
can.
the template I'm referring to is it's something like I've seen people doing it in multiple ways. It's like some people used some people used 2 for loops, one on the top to loop through the top window, one to loop through the second window. Some people used while loops and all. So the standard template that I think I would go with is like the reason I'm talking about template and like using standard is like, if you look at this problem, right? This is our first problem that we did, which is the fixed window sliding window, and this is the second one, which is the dynamic sliding window, and the third is what we'll discuss. But again, so if you look at the code, it's all like pretty standard. I mean, like this for loop, and then there's one condition here, there's a start pointer, there's an end pointer here, there is a window sum here, and there is a for loop which goes till the end, and there is a internal loop which moves the start pointer, and then it's kind of a same. So that way it's like you're not confused when you do it, right? When we started with the first problem, we were like we spent a lot of time on understanding like how do we move the window. But rather, once we know that it's a sliding window problem, we should have it pretty handy on like how we move the window, and then think more about the logic of like the logic that we were talking about, right? So in this case, the logic is also pretty simple, right? The sum has to be less than 7. That's the new logic in new problems. But other than that, the window, start index, second index, all these things are pretty standard. So the template I'm talking about is like how do we make it standardized, like moving the window, moving the start and end pointers. So I don't know if it made sense to people, but
So can we run
go
this
through the
code in
problem.
lead code?
Yeah,
Like this
I'll
one,
go through this
solution.
problem. Sorry?
Can we run this in lead code, this solution, whatever you have here?
Oh, okay.
I don't know if the function name is same as in lead code, or you just have to.
Okay.
I think this is for the first one.
The first one is the.
Okay. Yeah, sorry.
The second one. Okay. If you look at this, I followed the same approach like what we did when I was explaining the problem, right? So this is the minimum sub-window size that I want to do. And I have the start pointer here and the local sum, which is like maintaining the window sum that we are doing. So what I do is like, until we meet this condition, I'll keep adding to the window sum. So I'll keep adding to the sum, make a sum of it. Whenever I meet the condition, which is greater than or equal to 7. So that's the logic we were talking about, right? Saying that, oh, should we move the start pointer when we hit the 7, or should we do it only if it is greater than 7? So in that case, if you want to say like, oh, the 0 is not included in this, all we have to do is like remove this equal to. But yeah, so once we meet the condition,
what is
exactly
K
what sorry?
Is that S? K is not a variable.
Oh, that is.
Yeah. I copied from there, but I use the conditions here. Okay.
You could just change the parameter.
So is that S? Yeah.
That's the only place we used. Yeah.
Okay,
Okay.
what if the element is not there at, okay, whatever the element we are searching for is not available, okay, is it handling that case here?
You mean there is no, there is,
Subarrays,
window
okay.
doesn't make the sum 7.
Window doesn't, okay. That's some, yeah, that's true.
Yeah. So I believe in what I have written, I've made it initialized as this one, int max. We could
as a default, yeah.
Yeah.
But
So
this can be set to 0. Then what happens? Like if we set it to 0, then that condition will be handled.
Yeah.
But since it's for the positive number, I think we can set it to 0 as well.
Okay,
yeah.
while returning it, we can add a condition, right? Like minimum subarray size is same as the int max, or it has been changed later.
Yeah.
So that we can return a -1 or something.
Depending, I think here they meant to return
Zero.
Zero.
Yeah, 0.
Depending on what
you
want to return.
Add a condition at the line 35.
Oh, you mean?
Yeah, if it is int max, then return 0. Otherwise, return min subarray.
Whatever the min subarray says.
Okay. You said is equal to int max.
Yeah.
Underscore max. Return
0.
Yeah. Otherwise.
Max subarray size. Yeah.
Minimum subarray.
Good point.
Yep. That's right. Okay. So yeah, that's a good point. Yep. Thank you. So basically whatever I've explained on the top, so what I'm doing is like I'm maintaining the window size here, and whenever I get the window size that I'm targeting, so I then get the window size here, right? Basically the way I get the window size is like n minus start plus 1, because whenever I get here, yeah, exactly, like it's because of the indexing, n minus start plus 1, that would be the window size at that point of time, or look at what was the minimum window size that we have captured so far, and then subtract the start, which is the start pointer, because I'm shrinking the window from the start. So I'll start shrinking the window from the start by subtracting until I get to a point where this condition breaks, right? And then once the condition breaks, then I start expanding the window from the end. So that is taken care by this outer for loop. Outer for loop is basically taking care of moving the expanding the window until we break the condition, and the inner while loop is taking care of like once we break the condition, how do we shrink from the start. So any dynamic window problem, that logic is same, right? And the conditions that you have to change are like, what do you want to do? Are we calculating local sum and doing shrinking based on the local sum? Or is there any other condition? There are like multiple conditions, there are multiple problems with different conditions. But here we are only doing the local sum. Based on the sum, we are moving it.
Would that cause index outbound exception if the sum equals 0 and the vector contain one element is also 0? Because on the while loop we check if we have local sum supposedly is equals 0 and target is also equals 0. So we keep loop through that, right?
Oh, you mean to say
if suppose in some case
0,
local sum equals 0 and s equals 0.
Okay, let me run this code and then take a test case. What you're saying is sum is 0.
0 is not a positive integer. They have given array of n positive integers. 0 is neither positive nor negative.
Yeah, that's actually that's an assumption we made that. Oh yeah, we made that 0 could be positive or negative, but that might be. I haven't faced that kind of a question. I don't know.
Try like 1, 1, 1 then.
But I think it's a good point, because I think Naga, the way we can fix it is like we can, in the while loop at line 27, we can check for like our end start is not greater than end. I think that way we can come out of that loop. Otherwise, if the sum is 0 and then array just have one element of 0 or multiple elements of 0, then it will keep on going in that while loop, right? It will not come out of the loop.
But 0, why you are taking as an input?
I mean, yeah, definitely it's a corner case, but there is something to discuss, or and this question can definitely come, I believe, in the interview.
Sure.
Yeah, I think that makes sense. I mean, if that's the case, then we should. I don't know. I want to read and see, like, when they say positive, should we consider 0 or not? What do you guys?
But it doesn't matter if it's 0, right? You could also try like the sum is 1 and then the array only contains 1. Doesn't that test the same thing?
Yep.
Sum is 1 and oh,
Yeah,
you're
S
saying
is 1 and then the array just contains 1, or what, like any value.
1 and the array says 1.
I don't think it should matter.
So you're saying that you don't have to check for.
Yeah, so
No,
that's,
for
I mean,
one-
that's, I've had that
for
thought
one it
too
will
of
not
like,
matter, but for 0 it will matter. Like for 1 it will not matter, but for 0 it will, right?
I mean, you could try.
I think it will matter because your sum is always 0, right? And then you keep on looping into that.
Yeah.
Yeah, you're right.
Yeah. So I think
It's a good, really good point, actually. I believe. And
Yeah, I've had that thought as well of like if you should also have a loop condition that like this, like that start is less than or equal to end. I mean, in all of the sliding window problems I've done, I never used that, and it seems to work. But I guess there could be cases where you might have a.
that's the only condition. Yeah.
so it says expected is nothing. What is the
Expected is
Yeah, so it's probably
the lead code. Yeah.
It's probably.
So yeah, lead code doesn't give 0.
Yes. Yeah. Exactly.
As an input, so that's why.
Yeah.
Oh.
Okay. Basically, if you guys got this problem, then the next problem is kind of an extension to it, expanding more on what this dynamic sliding window is using different conditions. So here our condition was pretty simple, which is like the sum is greater than or equal to some number. But the next one is adding one more condition to it, a bit different condition to it, where we need to use some auxiliary, different kinds of data structures to do this thing. I believe we did a similar problem like last time when Hanif was presenting strings, I believe. But I'll just expand, and I'll also show like how this same template can be used. That way, like we don't have a confusion on like how do we move the window, what variables. So basically when I start a sliding window problem, I want to be like consistent using like, okay, this is my start, this is my end. My end is always tracking the second pointer. My while loop is starting the starting pointer, and my while condition says when I shrink. Those are the things I want to be like standardized whenever I know like I'm solving a sliding window problem. That's my kind of thinking when I was trying to solve these problems. I've seen like people doing different things. They use a different for loop to get to this condition first and have a different for loop, the different ways. Okay, so do you guys think I should move to the next question or?
Yes.
Yep.
Yeah, cool. Thanks, guys. Okay. I'll back. I don't know what happened to my. Okay. So by moving with that, moving to the next question. The next question is again given a string instead of numbers. Now we have a given a string. Find the length of longest substring in it with no more than k distinct characters. Right. So if you take this example, you have a string like this, ARAAACI. We want the longest substring with no more than 2 distinct characters. So if you take this example, actually, let's go back. I think this is there on lead code. Yeah, I'll take it to Java for now. just so that we don't. Okay. So here, unit string, find the length of the longest substring T that contains no more than k distinct characters. If you take this example, it's actually very similar to what we have done. Just the conditions that we use. Okay, am I jumping into the problem, or do you guys want to think about it a bit and tell what do you guys think about it? Does somebody want to take a shot at this problem to see how we would approach this one?
Yeah, so for this one, basically just to maintain, so the condition that you want to maintain in this case is that the substring contains at most k distinct characters. So the way I solved it was by using a hash map, where I'm basically just counting like the count of every character. And it's like you were saying, it's basically the same template as the previous problem, but I just have to like synchronize the state of the hash map with my current substring.
Yeah, that's right.
So, like,
we are
it's
using
clear
hash
that you
map
need to
for
know.
distinct.
It's
Right. So the
clear
hash
that you
map.
need to know the number of keys in the map because that tells you how many letters.
Exactly.
But,
So the size of the hash map will give you like that part at most k distinct characters. And then the reason I'm using a hash map instead of a hash set is because if you look at, like, say, look at the first example, right? Like the substring is ECE.
track of the positions of the.
I'm not keeping track of the positions. I'm keeping track of the counts. So when I reduce the window size, I reduce the count in the hash map, because there could be multiple, like in that first example, the answer is ECE. So if I were to shrink the window by 1, I would reduce the count of E by 1.
By 1.
Yeah.
That makes sense.
So I did similar, but I took, instead of taking the count, I took the first seen index. So if I've seen E 2 times, but I will only store the index where I've seen E for the first time. And then I'll remove something from the map which have the least index.
That's
but you see with ECE that the E appears twice. So if you removed the first E, it would still be in your set.
No, but I want it to stick. So I want, so first in my map, it would be E, then C, then E. Then as soon as
right, but once you hit the B, what I'm saying is.
Yeah, but once I hit the B, I already have a string of length 3. Once I hit B, I have to remove E. And still my length is distinct length is more 2, then I can use that window.
Yeah. I think that saves some comparisons, right? Still OFN, but that will save some comparisons.
I won't say this is OFN because we have a loop inside loop. In the worst case, we might end up doing a lot of things.
Is it?
But
no,
I think the loop inside the loop is fine. I think it's still open. Like if you look at the execution, even in the worst case, like I think in the worst case, you still make 1 full pass through the input string, because the 2 loops are not, like they don't have the same looping condition. Like the outer for loop will loop through the entire string, and then the inner while loop, like from the template, it's just checking to see if that at most k characters condition is met or not. So it's not the same looping.
Okay, so might be your solution is different. In my solution, I'm finding the smallest index, so I have to run through the entire map. Probably.
I see. Okay.
Yeah, it might be you are taking count. It would be different then.
Okay.
But in the inner while loop, we keep on incrementing the start, right? So that adds to some complexity, right? Bigger than big of n, right? Because outer loop is going through the right pointer, but the inner loop 2 max can go to the length of what is the difference between end and start, right?
But you're right. But start always has to be less than or equal to end.
Yeah,
so
but suppose if start is at 0 and then end reach to 100, right? to get to that
I mean,
condition
this is
within
still
the while,
ON.
you
Yeah,
move the
2n,
same
but
element,
yeah.
2n actually, it's 2n, that's what I believe. Like in
Yeah,
worst case, it could be
But
2 times.
2n is no different than n. It's not a,
Yeah,
we
yeah,
don't
Yeah,
care
yeah,
about that, right?
yeah.
But it's like 2 times. We might go at the worst 2 times, but which is n. Yeah.
Yeah.
So probably you can share your approach and then we can see the complex tree.
Yeah. Somebody wants to try with the template now that we have the template, or do you want me to share the solution so we can move to the next problems? Because all the problems, I think we kind of tried to fit in that template, or like we tried to use the same template. So
I think for time you could just show.
Yeah.
Instead of window end, here we go with window size, right?
Yeah.
Like hash map size.
Yeah. Oh, sorry.
Like in the dynamic, what is the sliding window pattern? Here we would be using the hash map size instead of using
the sum.
The window.
Yeah,
like
window sum. Yeah.
Okay, the number of distinct characters that came in.
Right. So yeah, if you look at this problem, like it's like I'm following the same thing. Like instead of having a local window sum, which we used in the earlier problem, here we are using a map because our condition here is like a distinct characters, right? So other than that, if you look at this one, the outer loop is taking the second pointer, and then as soon as I find an element, as soon as I find a character, I'm putting it in the map and also incrementing if that exists there, because there could be repeated characters, and when we remove a character, we want to remove only one instance of the character. So this is what this is taking care of by incrementing it. And the inner while loop is again just checking the condition. Our condition is like at most k distinct characters. So the inner while loop is doing that. And actually the code that I commented out, there was some issue that we faced. That's an interesting learning that we had. I can talk about it little later. But again, like once you get into the while condition, what we are trying to do is shrinking the window, right? So the way we shrink the window here, in our earlier problem, the way we shrink is by subtracting the start value, because it's all numbers. Here, the way we shrink it is we remove it from the map, which is the condition for this problem, right? So I use the same thing. Like it would have been like just number -1. Here we are removing it from the map. If that's the only character, then we remove it. If it is not, I decrement the counter for that character, and then I start shrinking the window by incrementing the start, and then we calculate the max every time, and then we return the max. So it's the same template, but the difference you see is like there in the earlier problem, what we wanted is sum of the numbers in the array. Here, what we want is the distinct characters in the string. So when we wanted a sum, we maintained a local sum. When we wanted a distinct characters, we are maintaining a map to make sure the distinct characters in the window that we are looking at is to the condition, which is k.
So worst case, this can go to n squared solution.
No, n.
I think so.
No, if I give you, so let's take an example like k equal to 2.
Mm-hmm.
And the input is A. Lot of A's.
Okay.
And then BC.
Okay.
Mm-hmm. So till all the A's are there, and when I reach B, I'm good. As soon as I add C,
mm-hmm.
my distinct characters gone up, and then I have to remove all the A's. But so in the while loop, I'll keep on removing one A at a time till I reach B.
Right.
So that's 2n though, right? Not n squared.
Yeah, that's 2n.
No, it's a loop inside the loop.
Oh,
So
no, but it doesn't matter though. Like it's
so
not
again.
No, but if I repeat this sequence multiple times.
So it is again same 2-pointer, right? Start and end. So end can be anywhere, but start. So both will go through whole array, let's say at max twice. But you are not basically going. So if the start pass one element, it is not going to come back again ever, right? Yeah. Same way, your end, once it is crossed that element, it is not going to come back ever again.
Yeah.
There's no way we are basically in moving the pointer in negative direction, right?
Yes, exactly. Yes.
Yeah. That's a good point. Whenever you move the pointer in the negative direction, then you're redoing it for that one. So that is not.
Sorry, why is this being brought up? What are we trying to solve that came up?
Complexity.
Oh, so it must, since you can't move it backwards, it's definitely less than 2n.
At most 2n, yeah.
Asim, does it make sense or still you have doubt about it?
I think I have still doubt, but I'll try myself.
If you want, we can run through the example, but it would be the same as like what we did last time. Actually, it's just like instead of maintaining the sum, we'll maintain a map, and we have some more problems of similar kind. So maybe that will make more sense.
Yeah. Asim, you could think so. Like Bhavesh was saying, so start and end never go backwards. So at the very worst case, like both start and end will loop through the whole input, which is I think what you were going for with like A, and then at the end you have something different.
Yeah, we are not going by the correct direction.
So both, so both of the, if both loop through like one pass, that'll be like 2n, which is like still O of n.
Yeah, sounds good.
So your idea, when you said to use a map, I'm not talking about this kind of map. I'm talking about where you actually keep track of the last index. Is that just so you can basically like make the start pointer jump?
How could keep track of the last index work?
Sorry?
How could it work?
So for example, someone else suggested this earlier, where let's say for A you say, okay, the last place that A appears is, I don't know, 5, wherever it is. So if you can you scroll up just so I can see the string, the example that you had? Yeah, so it's on line 22. So you see that you have a bunch of A's, and then once you hit that C, it's not that important, but you could say, oh, well, this this first item is A. Why don't I just move the start pointer to exclude all of the A's that are there? Because if there's any A in the section that I've already traversed, then it won't satisfy the condition that there's there are only 2 distinct characters. So I'll just like push it all the way up to the last time that I saw an A. So
but what if you have like
who was talking about that earlier?
If you have E or B in the middle, right, of A, then somehow you have to, decrease the B
exactly.
and C.
You do have to do that. I agree. So that was the thing I was worried about.
Asim, do you have that?
It's still doable.
Oh, do you have that code, Asim?
Yeah. What is the exact question for me?
Basically, any element where the last time it was seen is not is earlier than where your new start pointer is, you drop it from the set.
So yeah, so I was
mean, it's doable. It's just I don't think it saves it. I don't know if it's worth the extra effort to implement a solution like that. Like it's obviously not as it might not be as readable,
Yeah, but Asim, I think it will be good if you can share that your solution in the Slack channel so that we can just go through it and analyze it. Like when you say you're dropping the index.
So who was it who proposed doing that solution?
Yeah, I have proposed. So we can do right here quickly. So for this example only, what I was proposing for A, instead of taking count. So first, when I've seen the A, Naga, you can write it.
Yeah.
You can write there itself.
No,
oh, you're giving me this control. Okay, thank you. So what I was telling, like when you have seen A, just record 0. Then when we have after like if A is coming, I'm not changing it. Then when B is coming, then I'll record 1. And as soon as C will come, I have to remove something. I'll remove that entry which has the lowest index, which is A. So this is gone, and then I can add C here, which is, sorry, B was not 1, B was something
6, right?
6. It is going so fast for me, sorry for that. And then I'll put 7. And if I'm seeing a B after that as well here, then I won't update the B. So that was my
So are you tracking the first or the last index?
First time when I've seen it. So it's easy for me to remove. So for it, it would be easy for me to remove something which has the least index. In this case, A. But if I just flip this to a different, yeah. So that was my idea basically. But again, you might end up looping through.
How do you know
no,
B
I'm
is
actually,
first?
this is not the
what
idea
it sees
that
first.
I thought you were proposing.
No, this is the idea. That's what I'm proposing. I know for sure.
Okay. Hey, Asim, I think let's move on. You can share the different solution that you have.
Yeah, I think that will be helpful to analyze it, like, and then compare with this solution. And
no, both solutions are pretty much same. In one solution, we are taking the count. Other solution, we are taking the first scene index. I don't see they are too different in terms of complexity.
Okay.
But for your solution, don't you have to sort the second index to see what will be the next one?
No, so basically I don't have to. So I have to go through the. I have to go through this map and find which has the least index.
Yes, but let's say after you remove A, how do you know you're gonna pick B or C?
So as soon as okay. So what is the K here? K is 0, right?
Oh, so you loop through the math.
So as soon as I remove A, my map size became 1. It can accommodate now one more character.
Yeah, but the size will be 10, will be 100, right?
Well,
whose size?
The map size could be like 100 something.
How can the map size?
No, he's saying
it's
that
equal
he's
to the size of K.
He's keeping it to the size of K, but my issue is why are you recording the first time you see the element rather than the last time you see the element?
Because it could be like this. Let's say that's a good question. Yeah, thank you for bringing that up. So let's say it was like this.
Mm-hmm. That's exactly, yeah, that's the situation I wanted to present. So
yeah, so then we have C here.
Mm-hmm.
Then as soon as I see, I want to remove A. So this should be removing something which I've seen for the first time, which then this A will be gone.
Oh.
Okay, but then where are you moving your start pointer to? Because you have the start of your window. Where are you moving it to?
Yeah.
1 second. Let me see that.
So in this example, A would be 0, and for B you would have put in 3, right?
Mm-hmm.
And then once you hit C, which is at position 7, where are you moving your start pointer to once you delete the A from the set?
Okay, let me switch this. So I think you're right. It should be the last time when I've seen it.
Yeah.
Yeah, okay.
So this should be 6, and then this should be 3. And if something has to go away, which should be B. And then, yeah, B has the least index.
No. I think
would not do that.
we're mixing like two different things. So I think what you're saying, Asim, is that you loop through that map and you find the lowest index, and then that's what you remove. Whereas what we were actually thinking was that, like, for the sliding window approach, you record the last index, and that way you can just like sort of sweep up the start of your window up to that last index.
Instead of doing one by one, you use the index to jump.
But so Asim, so I think if you do it that way, where if you're tracking the first index and you're looping through the entire map to find the lowest index, so I think in that case you could.
Yeah, in this case, priority queue would be useful, but
yeah. But we also need some property of a map. If I'm seeing A again, which I could not do in the priority queue.
Yeah, I think because
I think Asim's approach doesn't change the way the sliding window operates.
Yeah.
It's the idea is to use those values to calculate the size of the window or something like that.
Yes. So basically, it will only change this part, which is this while loop.
But I think the complexity would be order of k times n in that case, right? Because you have k elements inside of your map, and then you have to loop through the entire map to find potentially loop through the entire map to find the lowest index, right?
Yes, but if I find it like the first place, I'm good.
No.
But so like, let's say k equals n, then it's like an n squared solution.
Yes,
yeah.
But that would be the same situation which we have discussed earlier. If I have a lot of A's, I'm reducing the count.
Yes.
Till I find with any element which has count 1. I'm still doing the same kind of operation, going through the entire hash map to find when the count will become 1.
Yeah, but it's like if it's k times n, then the worst case is like n squared if k is like approximately n. Whereas with the original solution, it's still order of n because it's just like 2n.
2 times.
Right.
Right.
But yeah, I mean, interesting like way of looking at it. Yeah.
Maybe we should
we could move on.
What's the follow-up problem to this one?
What's the, sorry?
Was this the last one in the problem set?
Oh, no.
Or was there another one?
2 more actually, but kind of similar format. So yeah, I'd let Sumeet, do you want to share? Sumeet has like 2 more problems.
Yeah, I don't know how we are. I think we are almost out of the time. So if we want to stay, we can continue. Or but pretty much like if we have understood like first 3 problems and the patterns around it, so they are just based out of the same approach. So just let me know. Like, do you want to go through them or?
Sumeet, I can propose something, right? So since we followed the same template, I would explain the problem and show like how the same template solves both of those problems.
Yeah, sure.
What do you guys think?
Okay, I can do that.
Sounds good.
Yeah, I mean, I think we can spend a few more minutes to go through that.
Yeah.
Okay, sure. So I have to share.
Yeah, I think you have to share. Maybe I have to stop sharing.
Yeah. Okay. So do you see my screen?
Yeah.
Yeah.
I see it.
Oh, okay. Yeah. So so this was the next problem. Maybe I can start. I mean, this is a little big, and the fourth problem is a little bigger, and but the idea remains the same. So I'm not sure if you want to read through it once and then we can discuss, or I can explain the problem right away. So
go ahead and explain.
Yeah, so basically this is the problem which is same as the first problem, where we say that the sliding window is of size fixed length. and the solution is pretty much similar to, I think, what Leon has coded earlier. And also we can do we can also solve this problem in the template format as well, because the first problem for the fixed length, the way we tackled, we had a if condition and then we went into just one for loop, right? So I did this problem in both the ways, like fitting into a template just to make it standard, the approach what we are trying to discuss for the sliding window. So the problem, if you want to take a minute just to read the problem, and then we can discuss about it.
The only thing I'm unsure about is, so they show the example, and what I'm not sure about is, so they give you the array for Grumpy.
Yep.
But then they tell you that basically that he can change it. So
yes,
some of these values could be changed to zeros.
Yes, you're right. So the way, yeah, go ahead.
Yeah, okay. So what I'm not getting from that is how they arrived at the total of 16.
Yeah, sure. Yeah.
Did they just multiply out? Did they take the products from all the other ones? Plus
yeah, you can say that
the
actually.
12 that are guaranteed.
Yes, exactly. I mean, you can say that, because I was looking into some of the discussion for this problem, and they have a solution where they do multiply these both arrays, the customers and the grumpiness, because one is, so basically the problem is that,
you could flip it. Yeah, the problem's presented in a strange way.
Yeah, exactly. I mean, that made it a little tricky. I'm not sure for an interview, like explaining this problem and within the time given, this seems to be a kind of little big problem, but the approach is pretty much the same as the first problem what we did, where we had a fixed length window and we want to maximize the window or the time for the owner to satisfy the maximum customers, right? So in this, so anyone have any other question around the problem? Then I can just talk through, like, how did we get to 16? Anyone have any questions?
This really looks like it looks like the problem where you're just literally maximizing you're finding the window with the maximum sum.
Yep, you're right. Exactly. So basically what we are trying to maximize is this window which is given to us, like here X is 3, right? So there's a bookstore owner who wants to maximize the number of customers he's satisfied within this time frame, where the customers indicate the number of customers visiting the store, and the grumpy array indicates like when customer was grumpy. So when he is grumpy, that means he is not able to satisfy the customer at that point. So these zeros and one indicates, if it is 0, then the owner was not grumpy. That means if it is 0 here, right here, so that means he can satisfy one customer at that point. But if it's 1 in the grumpy array, then at that point there is no customer. So he's not satisfying anyone anyway, because even though he's grumpy, so that doesn't matter, right? So this flows like so. So for the point where we have 0, 1, 2, 3, third index, where it says that grumpy of third is 1, that means he cannot satisfy 2 customer at that point, right? So similarly, this keeps on going, but what they have given is there is a secret technique with the book owner with certain range. So what they are saying is that if this range is given, so the book owner can satisfy the customer straight away for this range. Okay, even though he's grumpy, but for this range, even if he's grumpy for this range, but if he's satisfying more customer in that range, so he will definitely select that range to satisfy the customer. So this is similar to the problem what we did, the first problem where you have been given you have to max out the sum, right?
And
yes.
we will, for maxing out, we will just consider only the one with the ones or zero also.
Yeah, that's my question, because like, okay, so let's say if
What
you
was the question?
find
yeah, exactly. So we can max out with both. So since even if he is grumpy at that point, right? Even if his grumpy of I is 1, but since he has this power basically for that window, so he has to identify that where he can max out for that window.
right.
So
I think the question is like, so suppose so
we
okay, so
got-
if you find the maximum sum, like subarray of size X of customers, what if all of those happen to be 0 at that point in time? So you're not gaining anything at that
Right.
time,
Yeah.
in other words.
Yeah, you are not gaining anything, right? So
then wouldn't you want to choose a different, like, you know, a different set of whatever 3 minutes or however many elsewhere in the array to help the shop owner?
yeah, I mean, that is what we have to identify, right? So maybe I didn't get the like.
Okay, so my question is, when we see that we have to find the maximum window, maximum sum in the window of 3, the sum we'll consider only when the owner is grumpy, right? And we will basically ignore within that window any sum where the owner is not grumpy.
Yes.
Okay. So that's
there are two. I mean, I would say that it has two problems in it. One is the sliding window, and one is the total window in which you want to satisfy the maximum customer, right? So for the first part, you try to find a window where you can satisfy the max customer for that secret time, whatever he has been given, and then you sum it for the rest of the array, basically, right? So let me just walk through this example. Maybe then it will become more clear. So I'll just straight away go to the solution what they have given. So if we see this solution, so this is where there are max number of customers, right? Which is at the end, right? So if we directly, I mean, other win of size 3 exactly, right? So if we take other window, it will be the less number of customers, right? And in this window, since the grumpy of 1 is 1, so he cannot take this one, and I mean, without having this secret technique, he cannot use this one, and he cannot use this 5, right?
Yeah, so it makes sense to use it there. But suppose if those were like, so I think what you've said makes sense. But suppose those were 0.
Yeah, go ahead.
Suppose the last 3 entries in grumpy were 0, 0, 0.
Okay. Okay.
Then if he uses his secret power for those last 3 minutes, he's not gaining anything from it.
Yeah, that's what I'm trying to say, that he will not use that, because that is anyway is available to him, right? Because he was not grumpy, so he will satisfy these.
So how
he will use it for this one actually. He will use that window for this particular subarray where it is. He will be maximizing it, like satisfying more customers, right? Because at this point he's grumpy. At this point he's grumpy, so he cannot satisfy this customer. But with this power of this window, he can satisfy 3 customer at this point, right?
Yeah. So while
the question is, are you doing a simultaneous check on every, like, so for every window, for every window you check, you're doing a simultaneous check on the other array to check if they're all 0?
Yes.
Is that
Exactly.
what
I think
you're doing?
you're going towards the solution, but that's what the approach is. So,
okay.
Bhavesh, you were saying something?
Yeah, I was saying that basically we can just keep the sliding window and sum only where the grumpy is 1 within that sliding window, and basically while going through that pass also, wherever the owner is not grumpy, keep adding that also. So at the end, the maximum sum plus the answer would
Exactly.
be your answer. Yeah.
Yes. That's exactly the solution actually. So I'll just straight away go to the.
Okay, so it's very similar to the
On
first
this
problem.
one? Sorry.
Oh, it's very similar to the first problem. There's just some minor
Exactly. I mean,
tweaks.
what I'm trying to, stress on is that it's the same problem as like Leon coded earlier, where you have a fixed window size given, and then you try to maximize your customer satisfaction. So they have like tricked the problem a little bit, but it's the same problem. And just going to the solution. So I did this problem in both ways. Like as Naga was talking, that we want to follow a particular template, right? But it's a fixed window size, so you can just have a if condition, and then you can continue in one loop as well, right? I can show you that solution as well, but just to talk through, this is the same approach what Naga was talking, where we have a start and we have an end, right? So this outer for loop is nothing but the right pointer. And as I think Anne was talking, where we were saying that if it's grumpy, then we want to add to the sum, which is what we want to maximize. Okay. And then this is the inner loop where we are just keeping track of that, the secret time. I just gave a name where he has been given that fixed window, and I keep on decrementing it. And this is my condition in the while loop, which keeps on changing in every sliding window problem. That as soon as it becomes 0, that means I want to move my start and then continue on the loop. Okay. So, but the trick part here is that I only add to the sum whenever the grumpiness array tells me that. Like if grumpy of that index is 1, then only I add it to the sum. Otherwise, I don't. And I try to maximize that sum, and and this is also like little deviation or little trickiness, where if the start is index for the in the grumpy array is 1, then only we decrement from the sum. Okay, does this make sense? Like this particular, what I'm trying to say is that this is the same approach what we have been talking in all the previous three problems. So we have an outer loop for the right pointer and the inner loop for just moving the start.
Okay, so for lines 11 through 29, like that for loop, basically you're only concerned about where it's equal to 1. Grumpy is equal to 1.
Yes.
And then you add the zeros afterwards, because like you don't have to worry about those.
Yeah, exactly. So basically it's the same problem as the first one, but it has a little deviation that it looks for the other array to add to the sum. That's the only difference.
Yeah.
Oh, cool. So it's like the maximum sum of customers when grumpy is equal to 1. Yeah.
Basically, we are trying to find the max window when the maximum sum for that window where owner is grumpy.
Yeah.
So that we can flip that window and try to get the maximum benefit out of it.
Yeah. I mean, I just commented this code, and this is the same solution we can implement for the first one as well, because this is the one which is making it a little different, where we have to check the other array to include the sum.
Yeah. And if you want to make,
yeah,
I'm a little confused about so.
Yeah.
Wait. Oh. Oh gosh.
So don't look at this for loop. I mean, this is something which Bhavesh was saying, or you were saying, I think, Anne, that we can do this calculation here as well. But for simplicity, I have just kept it outside. So once I find my sum, which is the max sum, right? I just loop through it again and then try to, wherever he is not grumpy, I just add it to my max sum. That's it. Does that make sense?
Yeah, well, I'm still. so why do you have this variable secret time? Like, I guess this isn't quite what I would have done. I think I would have been much more explicit about.
So this is,
Gosh.
I mean, we can do with X also. I mean, I just took a variable name, I would say, but you can just decrement X and then you can deal with that as well. You can just say X minus minus X here, whatever is your input, right? Maybe that will make it easy for you to understand. Let's forget about this particular variable.
No. What I'm trying to understand here is why are you playing with the window size here?
Because
like,
that's the question.
Doesn't X represent the X represents the window size, right?
Yes.
So why will it be? When will it be 0? I guess.
When will it be 0?
So if you think in terms of like loop invariance, I think if I understand this, at the start of the for loop of every iteration, it's a fixed size of X.
Yes, exactly. So basically, suppose here the example is X is 3, right? So you take a sum of these first three index, right? First three index based on the grumpiness, which is right here on 12 to 15. And as soon as it becomes 0, you just decrement the whatever is there in the start index, right? And then you continue your outer loop again. So you increment your end.
But at line 20, you are using while loop, but at 27, you're doing X plus plus. So while loop executes only once?
Yes,
no.
yes.
So
exactly.
Yeah.
I mean, whoever told that, I think while loop, just to stress that I am trying to keep this, we are trying to emphasize on this template for the sliding window problem, but this problem can be done just with an if condition here.
Yeah.
The way
Just
Leon
be
is
an if
solving the
condition,
first problem.
Yeah.
That was confusing.
So if we,
I mean, I have been okay. I thought I was telling this.
Yeah, because the first template didn't have while loop. I think it was
so if you don't compare it with the first template, but basically we are getting the first 3 and then basically going one by one.
Yeah, now it makes sense. Yeah.
Yeah, I've been telling the same thing. I think maybe I was not very clear. Sorry about that. But if you see, like, I have the solution. Like, when at first I coded this way. Okay, so I don't have a while loop here. Okay, does that make sense now? I don't have a while loop here.
Yeah. Okay.
So again, and not to confuse that, I am using X, but that is a trick time. Okay, I just used a variable here. And I keep on decrementing my trick time. And if it is equal to 0, I decrement my start and reduce that start value from the sum.
But on the start,
like,
like, can we have a while loop? We can like, decrement start and or increment start until we hit a 1.
So
we decrement start until we.
I mean increment, not decrement.
Yeah, I mean that is what we are doing, right? Because the trick time will become 1, right? At that point.
So I think once we reach the 0, trick time will never go back to X. It will be like +1 -1, +1 -1.
Yes, +1 -1, exactly.
Yeah, that's what I'm
going through array. Okay.
Yeah, maybe I think I confused by showing this approach, but
so yeah, once we reaching to 0, and then basically it's just one step. We always go into this if condition. We do the +1 and then trick time. I mean, for loop will do -1, then +1. So basically, then we are going one step at a time.
Exactly.
Okay.
But again, I was trying to emphasize the idea of what we have been talking in the whole session, that we are trying to follow a template, right? So that's why I did this problem this way as well.
And in this also we are doing same thing. Basically, we will always go into the while loop we will stay in the while loop only for once. So
Right.
we put, instead of while, we put if. That is also fine, because this is, we are not gonna go there, more than.
So it's like in the grumpy, if the entry for the grumpy are 0, then we still need to go to that while loop on line 11, but the max sum is not going to change. It's still 0, right?
Also, sorry. What I was trying to say is that instead of while, we put if. That is also fine, I believe.
Yes.
Because we go to while loop only once.
Right.
And this is exactly what it is, I guess. So, okay.
Yeah, I think, yeah. Thanks, Bhavesh. So Leon, I think just to emphasize that the first problem what we solved, we can do this with the while loop as well, but this while loop only run once.
Yes, but I'm saying, let's say if the grumpy, R is R0, right?
Okay.
Then, we run from that to that while loop on line 11, but when we come out, nothing changes. The max sum still equals 0. Then, we accumulate the value in the second while loop, for loop on line 32 and return the sum.
Yes.
So, yeah.
But eventually, this will go to this loop, right?
Yeah, you go even did not doing anything.
Yes, exactly.
Okay, yeah, this makes sense. And if we want to make that condition, I think that is what you were mentioning, Sumeet, at line 13, 14, 15. If you don't want to check that if condition, we can just multiply the customer end with the grumpy end.
Yes. I mean, that's what I saw the solution in the discuss. You will see that what they are doing is they are multiplying these two arrays so that whatever is 0, I mean, you might have to do extra logic where 0, you have to make 1 first and then multiply with the customer array. And then, because 0 is not grumpy, right?
No.
So that's where you can...
just to remove the if condition. I'm not telling the final count, we will just keep it. Just if you want to remove the if condition, you can, instead of checking 1, you can multiply customer start with the grumpy start and customer end with the grumpy end. So
Yes, we can do that. Yeah.
It is exactly same. I mean, it doesn't change any meaning. It's just the if condition removed.
Okay. Yeah. So
okay.
Any more questions on this template? Go ahead. Any more questions on this template we are discussing? Because that's what I think Naga has been talking about the same thing, and
yeah, I think once we reduce it to that template, I think this question looks very easy.
Yeah,
I mean, initially it looks like a complex question where we have to.
I mean, this kind of solution you might have to deal with. I mean, on the spot. Yeah, I think we can do it. This is more simpler, but definitely, since if we are trying to follow a template, then I'm not sure if all the sliding, whatever me and Naga has seen, like all the sliding window problem is solvable by this template. Like even the fixed length or dynamic length with the auxiliary map array or whatever. So yeah, this is one of the example. Though it's a fixed length, but I try to solve it with the template. And so we can move on. Yeah. And we can move on to the next problem maybe quickly. I hope we are okay with the time. But this is also a very interesting problem where it's not a fixed length. It's a dynamic length where you keep on shrinking your start until you hit your condition, right? So it's a similar problem what we discussed in like second and the third approach. Third one, we were using an additional data structure, but here what we have to do is, if you want to take a minute to read the problem, please go ahead, and meanwhile I can also explain this, what's happening here. So we have to take a ASCII difference of each character, and then we have been given a max cost So this should not go beyond max cost. The difference, I mean, sum of difference of the ASCII character of two strings. So in this case, if you see, we have A and B. So the difference is 1 between A and B. B and C is 1, and then C and D is 1. And D, E, F is 2, right? The difference is 2. So basically, we follow the same pattern. We will have a start pointer, which will always point to 0. And then there is an end pointer, which is going in a loop, right? That is an outer loop. And there is a max cost. So we keep on adding, and we'll have a sum, which is a current ongoing sum. And then there'll be a max sum. Max length, sorry, the current length and the max length.
Yeah, so it's basically like instead of using the sum and all, we are just calculating the cost, comparing the two strings.
And then your
condition.
And you have to maximize the length of the substring between S and T, which can maximize this cost.
Yeah.
I mean, equal to this cost, sorry, equal to this cost.
So it seems like in the template, your while loop condition will be while the current cost is greater than the max cost.
Yeah, max cost.
Yep.
You can.
So any questions on this problem? Otherwise, we can directly go to I can show you like the solution, but it's the same thing what we have been discussing.
Yeah, it's the same thing. So I think we can go.
It's the same thing. So if you see here, I have an outer loop, which is a right pointer, which keeps on incrementing on its like as the for loop goes on. And then I take a difference of both the strings character, the ASCII difference, which is an absolute value because S can have a bigger letter ASCII versus T or otherwise, right? So I take a difference and then I sum that difference. This is an ongoing current sum. And then I check for if my sum is greater than max cost, then I keep on reducing my start, right? And at the same time, whatever is the ASCII difference, actually it should be start here. I was just doing some changes. So I keep on decrementing from the start pointer and increment value from the start pointer, ASCII difference value, and then increment the start till this condition. Sorry.
You're shrinking the window like from the start.
Yeah, basically I'm shrinking the window from the start because in this while loop the end is fixed.
Yep.
And then once I come out of this, I try to find the max length.
Okay, so this is, I think, a dynamic window.
Yeah, exactly. Yeah. So we fix the end, and then as soon as we get into this while loop, we try to shrink the start until it reaches this condition.
Where do you? I apologize if this sounds stupid. Where do you ensure that the start pointer doesn't go over out of bounds?
Yeah, so that is something we discussed. I think we discussed one scenario, right? So that is something we can check here. But since the sum is always higher till the time we have reached for the end index, I believe this should never get into that loop. I mean, with that condition. But definitely it's a good idea, as we discussed in other problem where we wanted to check for end start less than or equal to end.
I mean, so imagine that you had. Oh, okay. I kind of see where you're going with this. But I don't know. Okay. Thanks.
Yeah. Again, I mean, just we are following that template. Basically, the outer loop is the right pointer and the inner loop is the left pointer until you hit the condition, right? And then you try to maximize or minimize based on the problem or the situation.
I'm just wondering, like, what happens if like the end element has a high, high cost. Let's say like changing A to Z.
Yeah. So
then how would you get out of that loop?
So is the same thing what we had, right, in the dynamic window question, where suppose and is a 9 or and is the highest value. But there was a one case where we consider, right, where we put 0 and all, where we were going in the infinite loop. We can check here if we, in any condition we are going in the infinite loop.
The condition is that sum is greater than max cost. So if it's like going from A to Z, then your sum will be like whatever, like large value, like 25 or whatever. So it'll like it's.
No, what I'm saying is, imagine that the last character in each of the strings, the first string is the last character is A, and
Sure,
the second string, the last character is Z, and your max cost is 3. So
then your sum will exceed your max cost, right? And you'll just break out of the loop.
Yeah.
It's like you're more likely to break out of the loop if it's a larger cost.
why will you break out of the loop? Our
Because the
condition
sum.
is that while the sum isn't sum the current.
Sum is like you're adding that difference to sum, the difference between A to Z.
Is it the right example, NA, you're talking about, or is it something we can walk through it?
You can run it. I think it's handling the case. Just run it and see.
I don't know. Maybe I think Anna has something in mind.
So okay, your start pointer at this point in time, where is it at? It's at
which index?
You don't have to think about the start.
It's at the same place as end, right?
Initially, right? But end keeps on moving, right?
It's based on the end pointer. So like the diff here would be like,
okay,
let's
so
say
the
25.
fact that so the fact that you increment it out of bounds, that other condition on line 13 is just preventing it from being calculated.
Yes.
Yeah. Okay.
So I mean, we had that problem in the other example where, because we were going in the infinite loop and we are going out of array bound.
Yeah. So do you actually need start less than or equal to end on line 24?
I don't think you ever need it.
This example,
we don't.
I don't think.
Yeah.
But I would suggest that it is safer to do that because there could be some similar problem which may run into this, like as we discussed earlier, right?
Mm-hmm. Yeah.
I don't know what you guys think, but I think it is good to do this. Even though we will not run into it, but just for the safer side.
Yeah, I mean, I could see both, because that way you're like explicitly, that's kind of like an assumption, like of all of these problems that start is always less than or equal to end. So I guess making that explicit in that loop probably is like a good way of doing it. But I've at least for lead code, like I've never used that condition, and it like always seems to work fine.
Mm-hmm.
But it's a good discussion point with the interviewer, because sometimes they get into some extra line of code we have written, or why do we need that, right? So we should know, like.
Yep. All right, guys. Quick time check. We are already 30 minutes. No more than. Okay, so I'm gonna stop the recording. I think we have covered all the questions. We can still continue the discussion.